Hey guys, Mr. Jorgens here. We're actually going to cover section 3.2 just in one Edpuzzle video. So there won't be a part 2 of this one this week. It'll just be this one 3.2 video on linear functions. Today's all about knowing whether a function is linear or not. Linear is our big word for the day. Make sure you're paying attention as there will be questions along the way. All right, so here's our definition. Our big word of the day, again, remember, is linear. So we talked about functions in 3.1. So once we know that a relation is a function, we can know that it is specifically a linear function if that function has, one, a constant rate of change. And constant rate of change, another word for that you've learned in the past in 8th grade is slope. So if it has a constant slope, that's one way that we can know that it's a linear function. And the second way is if its graph is a non-vertical straight line. So if we're looking at the graph and it's some sort of straight line, then we know it's going to be linear, right? Unless it's completely vertical. So something like this, that one is not linear. So any type of straight line that's not vertical, we know is a linear function if we know it has a constant rate of change or a constant slope. That would be another way we would know that the function is linear. So once it's a function, we can check for this second classification to see if it is a linear function. All right, so let's take a look at example 1 and figure out which of these functions is linear and which is not by looking at their graphs. In this case, I think trying to figure out a function is linear, the easiest way to figure that out is by looking at its graph. And the definition says that it's linear if its graph is represented by a non-vertical straight line. So if we look at number 1, it's not vertical and it is a straight line, so number 1 would be linear because it's a straight line and it's not vertical. Example 1b, this one right here, that one is curved, right? It's kind of like U-shaped, so this one is going to be non-linear, not linear, because it's not a straight line. So if it's not a straight line, then it's not going to be linear. So anything that is curved is non-linear. And this one here on part C, the problem with this one is that it's vertical, right? I need a non-vertical straight line. So this one's vertical, and I can't have it being a vertical line and linear, so this one's non-linear as well. If it was horizontal, meaning flat, left to right, that would be fine. That would still be a linear function, but something vertical, straight up and down, is non-linear. All right, we're going to try a few here. On each one, you're going to enter whether you think it's linear or non-linear. For number 1, we're going to be looking at this graph here. So that's our graph on number 1. Is that linear or non-linear? So this one on number 1 is not a straight line. So since it's curved, it's going to be non-linear. All right, so hopefully you entered non-linear on that one. It's not a straight line, so it's non-linear. Let's take a look at number 2 here. So on number 2, I'm going to have this one right here. So is that going to be linear or non-linear? So this one is a straight line and it's non-vertical. So since it's a non-vertical straight line, this one is going to be linear. If we take a look at a third one here, let's look at that line right there. Is that one going to be linear or non-linear? So this one, number 3, is a non-vertical straight line. You may have gotten confused because it's horizontal, but horizontal is not vertical. So since it's not vertical and it is a straight line, we're going to say this one is linear as well. The second way by which we can check to see if a function is linear is by checking to see if it has a constant slope or a constant rate of change. So in this case, I have 2 tables kind of presented here to see if we can check to see if there's a constant slope. And again, slope is the change in y over the change in x. So if the change in y and change in x is both constant, then we'll know that it is linear. So in this case, if I check my x's, I can get from my first x to my second x 1 to 3 by adding 2. I can also get from 3 to 5 by adding 2. and I can get from 5 to 7 by adding 2. If I look at my y's, I can get from 2 to 9 by adding 7. I can get from 9 to 20 by adding 11. And I can get from 20 to 35 by adding 15. So my change in y over change in x is not the same, because my change in y over change in x would be 7 over 2, 11 over 2, and 15 over 2. And those are not constant, so we would say that it is non-linear, since that is not a constant slope. Again, hopefully you remember a little bit about finding slopes from 8th grade. If I look at part B here and look at my second table, if I look at my x's, 1 to 5 is adding 4, 5 to 9 also adding 4, 9 to 13 is an increase by 4, so I have a constant rate of change in my x. My y's, I'm adding 8, and adding 8, so I have a constant rate of change in my y's as well. So that would mean that it would be 8 over 4, 8 over 4, 8 over 4, or just a constant slope of 2, right? So I would say m equals 2 if you're a little bit about slope from 8th grade. I don't really need to know that level of detail though for today. I just need to know that it is a constant slope, regardless of what it is. It just is a constant slope. So if there's a constant slope, I'm going to say the function is linear. All right, let's take a look at 2 try these problems to finish off the day. The first one, we have the table there presented. Go ahead and decide whether that table would represent a linear function or a nonlinear function. All right, so on this one, if I look at my change in x's, it's a constant rate of change. I'm adding 3 to get to each x. And then my change in y's is going to be subtracting 6. So if you ever have a constant rate of change in both your y's and your x's, you know it's going to be linear. My change in y over change in x is negative 6 over 3, which is just negative 2 in all cases. So I'm going to be able to say that it is a linear function there on number 1. All right, go ahead and try your second try these problems. It'll be the last one of the Edpuzzle video. Decide whether that table on number 2 represents a linear or nonlinear function, and enter your answer when you're ready. All right, we take our look at our answer on this one. I have a change in y over change in x of negative 8 over 1, negative 4 over 1, and negative 2 over 1. That's not the same. So if you notice, I have a constant rate of change in my x's, but I don't have a constant rate of change in my y's. So that function is going to be nonlinear. All right, thanks for listening today. That kind of wraps up section 3.2. We'll move on to section 3.3 starting next week.